Hello, I am Justin, and today I'm going to show you how to convert a binary search tree to a circular doubly linked list. So basically going from this shape to this shape. First of all, if you find these videos helpful, please subscribe, or leave a comment, and let me know ways that this can improve, or if you have any questions that I could help you with. First of all, this is our binary search tree. Notice we have two nines. That's on purpose. We are going to do a depth first search in order to traverse this binary search tree in an in-order fashion. So that means we will recurse and then print and then recurse. Basically by the first recursion, it's recursing down the left, and that second recursion is recursing down the right. So starting at the root node, which is 9, is there something to the left? Yes, there's a 7. Is there something to the left of 7? Yes, there's a 4. Is there something to the left of 4? No, there's nothing to the left of 4. So we go back to 4, and remember, in an in-order traversal, this is the way, or in this point in the recursion, this is where we will do our programming work. And I'll show you what it looks like in Go after I go through this exercise with you. So we initialize 3 different variables, and these variables are pointers to nodes. So first, there's nothing assigned to first, so assign 4 to first, 4 to last, and 4 to current. Because there's nothing else, there's no other node to set it to, we'll continue to the next point in the recursion. So going back to 7, so current becomes 7. So last.write, we set this to current. So we connect 4 and 7. And then last, which is 4, we connect that to current.left. So then this creates the notion, or the concept of that doubly linked list. So we've got 4 and 7 pointing to each other, pointing to one another. Next, we go down to the right-hand side of 8. Nothing is to the left. Nothing is to the left. Then we set 7 as last, 8 is current. So last.right, we set this to 8, and then current.left, we set this to 7. 7 and 8 connected. Going back, 7 has already been handled. Going back, then we're on 9. Then current becomes 9. Last becomes 8. Last.right, we set that to current, which is 9. And last is set to current.left, which is 9. So continuing with our linked list. So then we go to the right-hand side of 10. Continuing our recursion, we go to the left-hand side of 9. Nothing is to the left of 9. Then we handle 9. So then 9 is both current and last. So 9 is connected with the last.right is connected to current, and last is connected to current.left. Then we're going on to 10. 10 becomes current. So 10 is now current. Last.right is connected to current. So we connect 10. And then last is connected to current.left. Got the doubly linked list continues. So we have 10. Then we are going to move to the right of 10, which is 11. And then we're going to move to the left of 11. Nothing is there. Then back to 11. So current becomes 11. And last is, of course, 10. So we will connect this and this. And then finally, we go to the right of 11, which is 12. So current becomes 12, last becomes 11. So last.right is connected to 12. and last is connected to current dot left, which is again 12. So the final step in this operation is when there's no other nodes on the left or right and we've handled them all, this will exit. On exit, then we will link up to make the list circular. We'll connect first and last. So first is 4 and last is 12. And that's it. I'll take you through the Go code now, and I'll show you what this looks like in Go. Thank you. All right, I'm going to show you how to do this circular doubly linked list converted from a binary tree in Go. So first of all, I'll show you what I've done. I've got this struct that is it's a node, so it's a type node. It's a struct, has a value, which is one of the numbers that you saw in that representation, left and right. And then in main down here, before I go over this, I want to show you main. Main, I simply initialize everything and connect all of the pointers. This represents the exact graph that I showed you in the last video. And then I call this tree to doubly linked list, passing in the root node, which is, of course, 9, the first 9. So how you read this is this takes a pointer to a node, returns a pointer to a node. If root is ever nil, then we return root. So it would return if nil is passed to it. So we initialize a first and last, and then we declare a function called DFS, which represents depth first search in order traversal. Just a quick recap what this looks like programmatically. We'd recurse, then we do our operation, and we would recurse down the right. So here's our DFS function. So it takes a pointer to a node. If node does not equal nil, we recurse down the left-hand side. So then if last is not nil, then we draw the connections. But if last is in fact nil, then we know we're dealing with the very first node. So we set current to first, and of course last is set to current, and then we recurse down the right hand side. So that's following that in order traversal. So remember, if last is not nil, we're dealing with something other than the first. Then we're dealing with something other than the first node. So we'd connect the right hand side of last with the current, and the left hand side of current with the last. So that creates that doubly linked list. So remember, when this returns, it's going to return with the doubly linked list created, but it's not circular yet. So in order to make it circular, we connect the right hand side of the last node with the first node, a pointer to the first node, and the first node, the left hand side of the first, with the pointer to the last node. And then this work down here I created simply so I could loop over and print out the return value. So this really has nothing to do with the tree to doubly linked list function, but rather just a means of printing it out. So basically I count all the way up to 8. 8 is the size of the number of nodes I created, and I print out the value, and then I set n to the next node. So, and I initialize that, of course, with the first node. So that would just print out all the values in line after they're sorted. And let me show you how this works. I will go with running it. So you can see 4, 7, 8, 9, 9, 10, 11, 12, just like we showed you in the last video. So I hope this helps you understand how to convert a binary search tree to a circular doubly linked list. If you found this helpful, please leave a comment. Please subscribe to the channel. And one last thing I should mention before I exit out of here. So the complexity, the time and space complexity is O to the n. Why is it O to the n? Each node is processed exactly once. By the way, this code is on GitHub with this nice README, and you can go over this yourself, go into the details of the algorithm, which I outline here, and I think that's it. Yeah. This is, oh yeah, by the way, this was definitely a Facebook interview question. So Facebook has uses this as an interview question. It's been flagged as such on LeetCode. So I hope this is helpful. Goodbye.